Welcome to Agentic AI World, your daily interview prep for AI and software engineering roles. I'm your host, and today we're tackling one of the most common system design questions in senior AI interviews. How do you design a conversational AI platform from scratch? Let's dive in. When an interviewer asks you to design a conversational AI platform, they're not just asking about a chatbot. They want to see how you think about scale, reliability, latency, personalization, and safety all at once. Start by clarifying the scope. Is this a customer service bot? A coding assistant? A general-purpose agent? Each has different requirements. For this walkthrough, let's assume we're building a platform like Claude.ai or ChatGPT, a general-purpose conversational AI serving millions of users. Step 1. Core components. The platform has 5 key layers. First, the API gateway and session manager. Every conversation starts here. The gateway handles authentication, rate limiting, and routes requests to the right backend. Sessions are tracked by a session ID. You store the conversation history, user preferences, and any active context windows here. Redis is your friend for fast session lookups. Second, the LLM inference layer. This is where the actual AI processing happens. You need a fleet of GPU servers running your model. For scale, you use horizontal scaling with a load balancer distributing inference requests. Key insight here. You separate the inference layer from the application layer so you can swap models without touching the rest of the system. Third, the context management service. Conversations have history, and LLMs have limited context windows. This service decides what to include in each prompt. For short conversations, you include the full history. For long conversations, you implement sliding window truncation or summarization. Compressing older turns into a summary that preserves meaning without burning tokens. Fourth, the memory and personalization layer. This is what separates a good platform from a great one. You store long-term user preferences, past conversation summaries, and user-specific knowledge in a vector database. At query time, you retrieve relevant memories and inject them into the context. This is essentially RAG applied to personal history. Fifth, the safety and moderation layer. Every input and output passes through content filters before reaching the user. This includes prompt injection detection, harmful content classification, PI redaction, and response quality checks. You run this as a sidecar service, lightweight, fast, but always on. Step 2. Handling scale. For a platform at ChatGPT-scale, say, 100 million active users, you need to think carefully about bottlenecks. The LLM inference layer is your most expensive and latency-sensitive component. You tackle this 3 ways. Request queuing with priority lanes. Free-tier users go in a standard queue. Premium users get priority routing. During peak load, you can shed non-critical requests gracefully. Streaming responses. Instead of waiting for the full response, you stream tokens to the client as they're generated. This dramatically improves perceived latency. Users see output in under a second even if the full response takes 5 seconds. Caching common completions. For frequently asked questions or system prompts, you can cache responses at the inference level. Be careful here. You only cache deterministic, non-personalized outputs. Step 3. The multi-turn problem. Here's where most candidates struggle. Conversations are stateful, but your backend should be mostly stateless. The trick: store all conversation state externally. Each inference request is self-contained. It includes the system prompt, the retrieved memories, the recent conversation history, and the new user message. The inference server doesn't know or care about previous requests. This means any server can handle any request, which gives you true horizontal scalability. For very long conversations, you implement a summarization pipeline. Every turns, a lightweight model summarizes the conversation so far. You store this summary and use it instead of the raw history. The user never notices, but your context costs drop dramatically. Step 4. Data architecture. You're dealing with 3 types of data. Real-time session data, stored in Redis with a TTL of 24 hours. Fast reads, ephemeral. Conversation history, stored in PostgreSQL with proper indexing on user_ID and timestamp. You'll need this for compliance, billing, and fine-tuning. Vector embeddings, stored in a purpose-built vector database like Pinecone or Weaviate. used for memory retrieval and semantic search across past conversations. One key design decision: separate your hot path from your analytics path. Don't let your analytics queries slow down live inference. Use event streaming, Kafka or Kinesis, to asynchronously copy conversation data to a data warehouse for analysis. Step 5. Reliability and observability. 3 things every interviewer wants to hear about. Circuit breakers. If your primary LLM goes down, automatically fall back to a smaller, faster model. Users get degraded quality, but the service stays up. Distributed tracing. Every request gets a trace ID that follows it through every service. When something goes wrong, and it will, you can pinpoint exactly where. Latency budgets. Define SLOs up front. For a conversational platform, you might target P50 latency under 1 second for first token, P99 under 3 seconds. Build dashboards that alert when you're approaching these limits. Putting it together. In an interview, you'd sketch this out on a whiteboard in roughly this order: API Gateway Session Manager Context Builder LLM Inference Fleet Safety Layer Response Streamer User. The key differentiators that impress interviewers. Mentioning the separation between stateless inference and stateful sessions, the summarization pipeline for long conversations, and the multi-tier caching strategy. Bonus points if you bring up cost optimization. LLM inference is expensive. Show you understand the business reality. That's a wrap on conversational AI platform design. Tomorrow we'll continue with another deep dive. If this helped you, subscribe to Agentic AI World and share it with someone prepping for their next big interview. See you tomorrow.